In this video, we're going to talk about how you can manage running programs in Linux. We'll start off by taking a look at how processes or running programs are managed on a system level, and then we'll take a look at a specific facility that allows us to manage running jobs as a user or a regular user that doesn't have root privileges. So the term that you've already heard me use is processes, and we can think of each running program on a Linux system as a process. They fall into one of three categories, but the two we'll mostly focus on at this point are interactive programs, and those are what we've been running up to this point. Running a program at the shell that goes ahead and performs some task, and then when it's done, returns control of the shell back to us. The next thing that we've also been dealing with, or we'll talk about this semester, are daemon processes. And these are processes that run in the background. They're not attached to a shell, and they are things that are like mail servers and web servers that kind of listen for information to come in and just kind of do their own thing. And literally, they're like little daemons on your system. There are also this classification of processes called batch processes, and so they're not attached to a shell. They're submitted to a queue. And this isn't something I'll directly talk about in this lecture, but I just kind of wanted to throw that out there. So we'll mostly look at interactive processes and how to manage them in this case, although some of the stuff we apply to today completely, or talk about in this next section, completely goes for daemon processes as well. So let's first take a note of how we can view running processes on a Linux system. The commands that we can use for checking out running processes on a Linux system is the ps command. And you'll notice in this lecture that the prompts I'm using are hash marks, and that's because these are indicating that usually you would perform these tasks as the root user, although just viewing running processes on the system is something that you can do as a regular user. And so the ps command is a way to display all of the running processes on a system. In this case, I'm showing you the AUX set of options, which is actually more of a BSD way of looking at options with the ps command. There's also you can also use EF, which is another more System 5 way of looking at system processes. So what do these show you? Let's jump over to the command line real quick and take a look. So I'm going to use the ps command, which you'll notice by default ps shows me very little, and actually it's just showing me those processes that are related to my current login session. But if I do ps-awk, I'm going to get a lot of information. And you'll notice that if I scroll up through this, on the left-hand column, you'll see information related to the user that uses that owns this process. You'll see this column of numbers, and then you'll see, several columns of numbers, some dates, and then some information all the way off to the right about the actual program that's being run. And even though it's getting clipped from the console here, you can know that these are actual paths to processes or programs. So let's talk, we'll come back and talk a little more about what all this means. Let's go back to the slide presentation real quick, and we'll use that to break this down. Here's a little bit cleaner view of ps output. It's an older screenshot that I've got available. And so what you'll notice is in the first column, we have all of the users that are associated with a given process. So each process is a row in this view. And you'll notice that each process tells you who owns that process, because who owns it is really important as to what privileges and basically what damage it can do to your system. Process ID, every process on the Unix system is given a process ID, and this will be valuable to us moving forward. The earlier a process comes to life on a system, the lower its process ID. So the higher a process ID, the newer the process is. It shows us information about CPU usage and memory usage. Those are kind of really the most important pieces of information at the moment. If you come over here, you can see when that process was started. You can see the total elapsed running time for that process, as well as you can see the actual command itself. So kind of some pretty valuable things that we can get some information about processes. We can use this command to, see if there's a process that's tying up all our memory, or kind of seeing if certain processes are run by a given user. What ps-awk does is just give you a quick view of all of the processes on the system. If we jump back to the command line real quick, you can see that we can use this with grep, and we can talk a little bit about how we can filter processes using grep. So ps-awk by default shows me a lot of stuff. So let's say I just really wanted to see those processes related to, here's a user nobody, so that seems pretty interesting. So how about we do ps-awk grep nobody. And now I get to see all of those processes that are that contain information about the user nobody. And again, there's a lot of data in these processes, so notice that in this case, some of these are wrapping around on my terminal and they're not as clean and easy to read. If I wanted to see all those processes owned by me, I can just script JSON and get all the processes related to what I'm running. And if you look at the processes I'm running, I mean, I'm logged in to a GUI session, so all of those tools required for a GNOME session are going to be up and running. You can see that I'm running a couple of different bits of information. I'm trying to find something that, notice there's something about like a screensaver here. I'm actually running a terminal command. So there's a bunch of different things that are related to what I'm doing on the system at any given time. I notice that each one of these commands is given its own ID. So how else can we get information on the system? This is just a snapshot, but what if I want to see a continually running view of processes on a Unix system? One of the commands that you can use is the top command, and top will give you a regularly updated view of all of the processes on a Unix system. It's pretty helpful, and it looks an awful lot like the process viewer on Windows in the sense that it shows you the name of everything, and it's constantly updated and gives you a nice, quick way to view what's going on. There's also some commands that you can enter into top to kind of filter the information as top is running. And what you're going to notice is that we will go in and play around with top here in a second on the command line, but this will give you information regarding all the running processes on a system. There are different ways to sort this. It gives you information about CPU load, total number of processes running, and information about kind of just the general stress that your system is under, if it's under any stress at all. And again, you can still see process IDs, and you can still see who owns that and how much CPU and memory it's using. So let's go take a look at this command on the command line. To run the top command, you just type top, and it brings up this nice, constantly updated full screen view. This is a really nice way to get some real-time information about your system. So if you are running a Unix system and you want to see the load, say in real time as users come into work in the morning, and kind of just watch what happens as everybody comes on your network. This can be kind of helpful for something like that. Although probably what you do is write a program to just take samples and dump that out to a file and analyze later. But in reality, this can give you that view if you really like to watch things happening. And so what you'll notice is I can actually do a couple of things here. So just some really quick commands that you can use in top. If I type C, it'll actually sort all of the system information in here by CPU, showing me those items using the most CPU first, and then descending to the least amount of CPU. If I type M, it'll show me all of the items in top based on memory usage. At least I thought it was going to show me stuff based on memory usage. If you want to know all of these commands, you can type H for help. And you'll notice that I was correct. So load average, task, CPU stats, and memory. And so the help can be really useful. And when we're running top and you're done with it and you want to get out of it, you can just hit Q. And it will return you to your regularly scheduled prompt. So sometimes you're going to have processes and you're going to want to stop them. And one of the things that you can do is, because every process on the system has an ID, we can use that process ID to get some control over a process. So let's say you have a hung process or a process that, basically like you've got a locked up program and you want to terminate that locked up program, or you're running a process in the background and you're not real sure how it got there and you just want to stop that process. Or you notice that a user starts executing a really CPU intensive task at a really inappropriate time and you want to stop that task. So what we want to do is we want to identify the process ID of the task that we're interested in, and then we can use that process ID to kill that command. And in Unix, there actually is a command called kill. And now if you own the process, you should be able to kill it, but you can't just go killing other people's processes. Again, this is why I'm demonstrating the kill command with the root prompt here to indicate that usually killing a command requires the elevated privileges necessary to do that. So one of the things you'll notice here is that I focus on, in this, the command is kill, and there are two options that usually can give kill. The two I really talk about in this class are just -15 and -9. These are called signals, and basically you can send a signal to a process and it gives it some information. So you give the kill command an option that indicates the type of signal you want to send to the process, and then you give the process ID of that process. So what I'm saying is whatever process 876 is, I want it to terminate, and I've sent signal 15. And signal 15 is a way of nicely terminating a process. It's kind of like tapping it on the shoulder and then saying, could you please shut down? And if it's listening for that signal, it'll say, oh, yes, sure, I'll shut down. It'll go through all of its shutdown routines and then eventually clean up after itself and go down. If a command or a process doesn't respond to a -15 signal, you could give it a -9, and this is a fairly violent way to kill a process. It means that the process will be terminated immediately. The process will not go through its regular shutdown procedures, and this is kind of useful when a process is hung up. So the idea here is that there's a couple other signals that are of significance, but just focusing today on -9 and -15. And so we can take a look at how these are implemented on the command line as well. So let's take a look at how kill works. In this example, I've changed my prompt so you can see my username. So what I'm going to do is I'm going to run psaux and grep out just commands that are related to me, my user Jason. And I'm going to look through this list of commands. And if you notice, the terminal command that I'm running is right here. And it has an ID of 5512. So what I want to do is kill this command. And so what I'm going to do is, if I try to kill it right now, see if it works. It did. And it allowed me to kill that because I'm actually, I'm the user that started that command. I own the command, and therefore I was able to kill that command. If I rerun my terminal, and I run psaux and look for some root commands, if I were to switch to the root user, I would be able to terminate any one of these items that are actually running based upon any of these IDs. But if I try to kill one of them, let's just try to kill kworker, which is 4402. So if I try to kill that, I get an operation not permitted because I don't own it. If I were to switch to the root user, and I'm actually not going to do that because I don't want to mess up my session, then I would be able to kill that. So as long as you have the permissions to kill a process, you're able to do so. So in this case, notice that I'm just executing as the regular user and therefore have the ability to terminate any of my processes. The kill command is useful as a regular user, and sometimes you may find yourself using it as well as the top command and the ps command. But there's a couple of process control mechanisms in Unix that are really helpful to a user that doesn't have elevated privileges. I mean, the root user can use these facilities, but these tend to be much better for day-to-day use on the command line. Specifically, I'm going to look at a facility called the jobs command, and jobs is a really nice command because it allows you to see all of the current jobs that you have running at the command line at a given time. And you might be thinking to yourself, well, I can only run one command at a time. But what we'll do is we'll look at how we can actually run jobs in the foreground, run jobs in the background, and how we can actually pause jobs that are currently running in the foreground and put them into the background. So one of the things we'll start with is that we're going to use the command Control-Z to pause running jobs that might be taking too long and are tying up our terminal. This might seem like a little bit of an odd thing to do when we've got the ability to launch, if you've got a full GUI Linux installation on your desktop and the ability to just launch a new tab for a terminal. But sometimes it's helpful to, if you only have one terminal available, you want to pause what's happening so you can do more work and get the command line back. Jobs will allow us to see all paused jobs. It'll allow us to see all jobs that are running in the background, and it'll allow us to see recently terminated jobs. We're going to use the command FG and BG, and these are going to be useful that once a job is paused, we can put a job into the foreground or into the background for continual execution. We'll talk about what %n does when we go to the command line, but there's a quicker way than using full process IDs for identifying jobs that are in our existing job queue. And again, we'll use BG to put jobs into the background. We can still use kill with this approach. We don't have to use full process IDs. Kill is aware of this kind of user related jobs facility. And we'll also look at how we can start running jobs in the background using the ampersand command, which is just a really nice way if you're going to have some really long running job so you can start it in the background. So let's go over to the command line and see how this works. In this folder, I have a program called long process. This is a Perl program, and this program, when executed, just ties up my terminal. So I'm going to run it. It is executable, that's why it's green. If I look at the permissions of that file, you will notice that it is 777, which means I was lazy and just gave universal read, write, and execute permissions to that process. So now if I want to run it, I can use /long process to execute this Perl program in place. And you'll notice that when executed, it starts counting from 0 to 100 really slowly. And if this was an actual job, whether it be like a complex mathematical operation or some other time-consuming operation, what you might be thinking is, what do I do while this is processing? Again, we have a full GUI, so we could actually, in this specific terminal, we could go up to File and open a new terminal or a new tab. But sometimes you don't have a full terminal, so we need to pause a process. So we talked about the ability to pause processes using Control-Z. So I'm going to go ahead and pause this process. And what you'll notice is that it immediately gives me this indicator that that process has been stopped. And you can have multiple stopped processes associated with your jobs queue. And so in this case, if I type the word jobs, which is the command useful here, it'll show me all of the stopped jobs in my queue. If I want to start another long process, I can do so. And this is a separate process. And then if I pause that and I run jobs again, now you'll notice that I have 2 processes sitting in my jobs queue. Notice that the one with the plus next to it and one with a minus. This by default, the one with the plus next to it is the most recent item that was put into the jobs queue. That can be important at times, and we'll take a look why. Notice also that each one of these jobs gets their own ID. So notice that job ID 1 in this queue is different than the process ID 1 on your system, which is the low-level system init process. So these are custom process IDs just for your jobs queue. And so what's really nice is we can use these for doing things. So let's say I want to bring one of these jobs into the foreground. The command to do that is FG. And if I have multiple jobs in my queue, I can do %1 and bring that job back into the foreground. And now that job is no longer paused and it's back running and it's still printing stuff out to the command line. I'm going to pause it again and you'll notice that it has been put back into the jobs queue. Let me clear the terminal so we can see this a little more clearly. Notice that again, now process ID 1 is the most recently paused job, so it has the plus next to it. If I want to kill that job, I can use kill %1 and it will kill that job in my jobs queue. And now if I type jobs, you'll see that job 1 is gone. And now the most recently paused active job is that instance of the long process script. And you'll see that it still contains its number 2 actually. The job IDs don't change. It's just that now that's the only one left. So if I want to run that in the foreground, we already looked at FG, but I can also run this in the background. And by the way, if a task has the plus sign next to it, you don't need to use, I could either type %2, or if I just wanted to save typing a few characters, since this is the only job in my queue, and this is the job with the plus next to it, if I just type BG, it'll assume that I want the job with the plus next to it. This is a little bit of a strange script. Even though it's in the background, notice it's printing to my terminal. So I was just trying to, the way I'm running the script is a little odd. So I just want to kind of point out that this is still running. And by the way, notice at this point it's running in the background and I'm hitting Control-Z, and I don't know if you can hear that through the microphone, but notice it's not pausing the job. And if I type jobs, you'll see that it's there. And if I want to kill it, I can type kill %2. And the job will stop and it's gone. Also notice that these items that we're printing out to the terminal, they didn't have any effect on what I was typing into the command line. It just has to do with the way the jobs are being run and displayed on standard output and it's obviously standard input is what I'm typing into the command line. So in this case, I have some ability to control jobs. Notice that when a job is in the background, by the way, it ends with an ampersand. So anytime you want to start a job in the background, you can just execute that job and put an ampersand on it, and it'll go straight into the background. And you'll notice that if I look at this now, it's in my job queue and it's running. I'm going to fix this just to kind of show you. Notice I can't just type kill, by the way. I have to type kill %1. Notice that all of these numbers are getting in the way, so next time I run this in the background, what I'm going to do is just redirect that output to dev null so we don't see it. So now what I'm basically doing is, instead of having the output of this process print to the command line, we'll never see it. I'm just going to send it to the bit bucket. So now you'll notice that I've got this process running. Notice it gave me some information about the jobs queue. If I type jobs, it'll show me what is actually running. So this is my running job. It's in the background and it's doing its thing. And if I wanted to bring that to the foreground, I now brought it to the foreground, but notice how it ties up my terminal, and that's kind of annoying. So I can pause it again, and I can start it in the background. And it's up and running. And again, so we can kill jobs, pause jobs, and put them in the background, bring them into the foreground. It's a really nice way to manage jobs, and it's really helpful.